Hey guys, welcome back. We're doing triple integrals and spherical coordinates. And so this example is asking us to use spherical coordinates to find the volume of the solid region bounded below by the upper nap of the cone z squared equals x squared plus y squared. And it's above the sphere of x squared plus y squared plus z squared equals 9. And we're given the three equations that you can convert from Cartesian over to spherical, which we're going to use here in a little bit of time. But the first thing that I always like to do in these problems is actually look at the bounds for our three coordinates. And so the first one we're going to do is we're going to talk about rho. So rho, we're going to look at, well, the lower bound for rho is actually going to be the 0.000, right? It's a sphere. And so the lower bound for rho will actually be 0 because it is actually at the 0.000. And then the upper bound for rho will be what, and I said this to you guys before, that these equations are written very nicely for us. It's convenient that they give us this, the sphere of x squared plus y squared plus z squared equals 9 because we know that rho squared is actually equal to x squared plus y squared plus z squared. So rho squared is equal to 9. So that means that anywhere on the surface of our sphere, so any point here, any distance from 0.000, that's going to give us a distance of 3, right? So go ahead and erase this. But that is going to be the upper bound that we're going to be using for rho. All right. Then the other one, theta, is actually really easy to also figure out because the fact that it's a sphere. So we start at the positive x-axis, and so our lower bound is going to be 0. And we're actually going to go all the way around, right? The sphere goes all the way around to where we hit 2 pi. So theta in this case is going to be from 0 to 2 pi. So those are actually pretty easy for us to figure out. So let's talk about phi. So phi is going to be, let's remind ourselves what phi actually is. So on the positive z-axis, phi is going to be the angle from the positive x-axis as we're going down. And so we're looking at the upper nap of the cone, right? We want to find the angle of this cone. And they're giving us the equation of z squared equals x squared plus y squared. So we're going to use this equation and our conversion equations to actually figure out what we can do for phi. So we're going to have z squared as rho squared cosine squared phi is equal to, well, x squared will be rho squared sine phi squared cosine theta squared. And then y squared will be rho squared sine squared phi, then sine squared theta. And when we're looking at this, it's like, okay, that's a little crazy. However, again, I'll keep saying this, these questions are written very nicely for us. So we're going to rewrite the equations with a little simplifying here. And I'm going to leave the left-hand side completely alone. So what we do notice in the right-hand side is there is two things that both of these functions have. So we can pull those out and distribute them. And the first one is going to be, we have a rho squared. And we also have a sine phi squared as well. And so what's left over, right? So what's left over? Well, conveniently for us, in the first term, there's a cosine squared theta. And in the second term, you guessed it, is a sine squared theta. And we love this identity. We know this identity. It's awesome. We know that cosine squared plus sine squared is equal to 1. So this whole thing right here is now 1. So that kind of is now gone. And what other amazing things are starting to happen here? Well, the rho squareds can also cancel. And we have a cosine squared and a sine squared. And so we can take the square root of both sides, and we get that cosine of phi is equal to sine of phi. And we have to also remember that phi can only be from 0 to pi. Again, it's the positive x, or the positive z-axis, right? And so the furthest down we can go is 2 pi. Well, the only angle that fits this criteria, that where cosine and sine are equal to each other, is actually pi over 4. So that means that phi is going to be from 0 to pi over 4. All right. So we've done what we had to do here. And so now we're going to look at our bounds, and we're going to go ahead and write those things out. So I'm going to go ahead and write down from 0 to pi over 4 for phi. We're going to go ahead and do 0 to 2 pi for theta, and then 0 to 3 for rho. We have to remember, guys, that when we're doing this, I'm going to change the color up for us here, is that when we're doing conversions of spherical, we have to add every single time a rho squared and then a sine squared phi. So let's always, always, always remember that, right? We have to always put those in our equations. And then we're going to have d rho, d theta, d phi. Okay? So, wait, not squared. Why am I doing that? Hold on for 1 second. My apologies. I made a big stink about this, and it's actually just the sine of phi, not sine squared. So, my apologies there. So we are always going to, when we do our conversion factors, we always do rho squared sine phi, right? Not sine squared phi. I don't know where my head was with that problem. So I'm going to fix that, make sure we understand that pretty well. All right. So one cool thing about this problem is we could do the old school integration of everything, but a friendly reminder of something that we learned when we were looking at double integrals is the fact that if this is a product, right, all these things are being multiplied together, what we can do is we can take each individual variable. So I can look at 0 to pi over 4 of sine of phi, d phi, oops, phi, let me change that, d phi, and then I can multiply this by the integration from 0 to 2 pi of, well, there's no theta here, so just 1 d theta. And then I can also multiply this by the integration of 0 to 3 of rho squared d rho. Goodness. Sorry, guys. My computer's being really slow right now. D rho. Okay. So that's really cool, right? And so we can actually integrate sine 1 and rho squared very easily. And so the answers that we get individually here is when we integrate this, we get negative square root of 2 over 2 plus 1. So for anybody that's doing this by hand and you want to just check each individual intervals, then we're going to get, this is going to be theta evaluated from 0 to 2 pi. So this is just going to simply be 2 pi. And then we're going to integrate rho squared, which is rho squared over 3, evaluate it from 3 to 0, which is going to give us an answer of 9. And then when we multiply all these together, we're going to get the answer, which is still going to be kind of nasty here, but we're going to get 18 pi times 1 minus the square root of 2 over 2. So this is going to be the answer to this problem. So this made us think a little bit, but we did good, we did fine. Like I said, the only thing that I want to just clarify one more time here is the fact that what we do add to our integral is actually rho squared sine of phi and not sine squared of phi. So anyways, hopefully this worked for you guys, and I will see you in the next video. Take care.